picture of a book on the table. There's a book, there's a table, here's a book on the table, and now there's this hand pushing on the book that way. So the book is sliding along the table to the right, and it doesn't have an acceleration. Okay, so it's moving at a constant velocity. I'd like to draw the free body diagram for the book. Who would be willing to describe it for me? Jack.
Draw to the right.
For a force pushing it to the right, let's put a letter on there.
What?
Let's put a letter to distinguish what is the source of that force.
The hand.
Okay, so H for the hand. What else? What other forces?
The gas pushing on top, or pushing on the book.
Which way?
Up.
Okay, so what do we call that force? Somebody help him out, I heard over here. Normal force, right? Perpendicular force, surface force. So normal force, go ahead.
Another force down for gravity.
Down for gravity. Equal to the normal force, right? And since we're moving at no acceleration, that means we're moving at a constant velocity. So that's the free body diagram for an accelerating object. Is there anything else I should add to that? Josh?
Friction?
Friction, which way?
Left.
Okay. Same size as the hand. And now, put an F there for friction. And now that tells me that our object is in equilibrium, right? It's not accelerating. So since we've been drawing free body diagrams, we've been drawing these arrows representing friction. We haven't discussed friction other than that. We haven't talked about what it is, what causes it. We haven't talked about how to find it. Like, in other words, what is its value to quantify it. But we know that it exists because we've all had experience with it. So let's consider something here. So I have this box right here. I got 2 kilogram masses in it. And I'm going to, here's a spring scale. All right, I'm pulling with a spring scale. I'm going to pull the masses. So let's say that I'm pulling, Alex, can you read that needle?
What side am I looking at?
Top one.
Newtons, yeah. Is that 2?
2 newtons. So I'm actually pulling the box with 2 newtons of force. Is it accelerating? No. Right? The box is not accelerating. So if we were to draw the free body diagram for that box, I would have a force here, scale, pulling with a force of 2 newtons. And since it's not accelerating, we know that there's an arrow going this way. What's its value? 2 newtons. So there's a force there, it's 2 newtons. What's causing that force? Right? The fact that the surfaces are rough, the friction force. Now that box has remained stationary, or another word for that is it's static. Box didn't move. So that kind of friction is present when the box is static or when it is stationary. Okay, so that first type of friction is going to be called static friction. We get that, and we're going to put an S there as well. So friction, force, static. That's the kind of friction that's present when the objects are not moving relative to each other, but there is a force being applied. So static friction is one type we're going to look at. The force exerted by one surface on another when there is no motion between the two surfaces. also important is this statement. The static friction will equal the applied force until the object begins to slide. So as I pull on this box with a force of 2 newtons, it doesn't slide. So the static friction equals 2 newtons. But now I'm actually pulling a little harder. All right, Alex?
Yep.
I'm pulling with a force equal to 4 newtons. So when I pull with a force equal to 4 newtons, we know that the static friction had to increase as well because we remained in equilibrium. So it equaled 4 newtons. So the static friction varies. When I don't pull on the box, there's no force. Now what's the static friction? 0, right? So it can go from 0, when there's no applied force, up to a maximum value. Well, once I get to the maximum value of static friction, what happens? If I pull harder, the box begins to slide. Now we don't have static friction anymore because we're no longer stationary. So now there's another word for that type of friction. It's no longer static. We're going to put the word kinetic there. Right? Kinetic, that word kinetic means motion, means movement. So once they're sliding, you may have heard it called sliding friction. We're going to we'll sometimes say sliding friction, but more often than not, we'll say kinetic. So when it's not static, it's sliding, it's kinetic friction.